Fiber optics information can be found in various resources. Good books to consult include Fiber Optic Communication Systems by John M. Senior, Handbook of Fiber Optics by Green and Maurer, and Optical Fiber Communications by Gerd Kaiser. Several websites also provide valuable information. The Fiber Optic Association for FFO.org is a good resource. Also consider Lightwave Online at lightwaveonline.com and Fiber Optics Communications Magazine at focoms.com. For specific articles and white papers, search for Fiber Optic Loss Budget Calculation by Cisco, available on their website as a PDF. Also look for Understanding Optical Loss in Fiber Optics by Corning, which you can find on their website. Lastly, review Fiber Optic Attenuation and Loss Budget by FS, which can be found on their products page. Online courses can also offer a structured learning experience. Consider courses such as Fiber Optics Fundamentals on Coursera, Fiber Optics course on Udemy, and Fiber Optics for Beginners on edX. Now let's discuss dB loss in fiber optics. Decibels, abbreviated dB, are units used to express the ratio of two power levels. In fiber optics, dB loss refers to the reduction in optical power as it travels through a fiber. This reduction is due to factors such as scattering, absorption, and imperfections within the fiber. The formula for calculating dB loss is 10 times the base 10 logarithm of the input power divided by the output power. Stated as a formula, that is, dB loss equals 10 times log base 10 of P1 divided by P2, where P1 is the input power and P2 is the output power. Typical dB loss values vary depending on the fiber type. High-quality fibers typically exhibit losses of 0.2 dB per kilometer or less. Standard multimode fibers usually have losses between 2 and 3 dB per kilometer. Single-mode fibers typically exhibit losses between 0.5 and 1.0 dB per kilometer. Several factors influence dB loss. These include the type of fiber, the wavelength of light used, the fiber length, connector losses, and splice losses. Higher losses reduce the maximum transmission distance achievable in a fiber optic system. This can lead to signal degradation and errors. Therefore, proper fiber selection and installation techniques are crucial for minimizing dB loss. It's important to note that dB loss is not the same as attenuation. Attenuation is the physical process that causes the reduction in optical power. dB loss is a measure of that reduction. dB loss is also used to calculate the overall loss budget of a fiber optic system. The loss budget represents the maximum amount of loss allowed without compromising system performance. Understanding dB loss is crucial for designing and troubleshooting fiber optic networks.